So last time we looked at this data set where the points are 1, 1, 2, 4, and 3, 3. And then we looked at this loss function. These are all different ways of rewriting the same thing. So classically in statistics, you would use y hat for the prediction versus y for the actual. Parlance of sklearn, you're seeing y prediction and y true. The predicted value is going to be a function of these m and b parameters. These m and b parameters, how do you predict? Well, you plug in to mx plus b to make your prediction, and then your true value is coming from whatever the original data set was. Do you agree? Okay. Well, now let's look at the method that you use to actually find the optimal parameters for the original prediction function, not the loss function, but the actual prediction function of the y hat equals mx plus b. So for reasons that make sense to me, I don't like the y hat. I'm going to call it p of x equals mx plus b. Are you okay with that? So p of x is m times 1 plus b minus 1 squared plus m times 2 plus b minus 4 squared plus m times 3 plus b minus 3 squared. Let's ask ourselves a tough question. What is partial derivative of p with respect to x? What is the partial derivative of p with respect to m? You're right, I should have said m instead of x. It's really important. It's going to be 2 times m times 1 plus b minus 1 raised to the 1. And then I'll have to do chain rule, so I get that times the coefficient on m plus 2 times m times 2 plus b minus 4 to the 1 times 2 plus b minus 3 to the 1. Definitely am. Thank you for catching that. I really appreciate that. M plus, this is why you don't try to do it quickly. As soon as I start trying to do it quickly, it's plus 6 times 18 plus 18m plus 6b minus 18. So at the end of the day, partial p partial m is equal to 28m plus 12b minus 36. Do you agree? Let's do partial p partial b, which will basically be the same thing, except we'd be multiplying by coefficient on b, which is just 1. So I'm going to have 2 times m times 1 plus b minus 1 times 1 plus 2 times m times 2 plus b minus 4 plus 2 times m times 3 plus b minus 3. I agree. I really appreciate you catching my mistake, and I hope that people will, engage. And if I've done something wrong, I really appreciate when y'all point that out. So this will be 2m plus 2b minus 2 plus 4m plus 2b minus 8 plus 6m plus 2b minus 6, which is 12m plus 6b minus 16. This is partial m. Now, if I wanted to, I could try to solve these equations for m and b set equal to 0. So it would be an option is a technique called gradient descent. And the way that gradient descent works, well, something that's important that I want you to know is that gradient descent is a technique for finding local minima. Can you remember that? It's really big. Of 0, and it can be anything we pick. And then we're going to iterate and update that to give us our second iteration, or our next iteration, which will be a sub 1. And the way that we'll get a sub 1 is we'll take a sub 0 and we will subtract off this number. What is this? I don't like it, so I'm going to call it lambda instead. So a small gamma. I always use lambda because lambda stands for learning. This is called the learning rate. It determines how big your steps are. We're going to multiply that by the gradient of the function evaluated at whatever the previous. But what we calculated, now I did mess up here because, no, I did not mess up. Cool. All right, so my loss function was f, and hey friends, I did mess up though. I said this was delta p delta m. Do you agree? No. P of x is mx plus b. This is the gradient of the loss function of the prediction function p, f of m and b. Prediction function is a function of x. So this is not p of x. This is p. I did the partial derivative I needed to. I just didn't call it the right thing. This is actually the partial derivative. Sorry, this should have been partial f partial m, and this should have been partial f partial b. My apologies. It's an easy mistake to make, especially late, but we're going to have a gradient partial f of mb, and we actually found the two components of this. We found the first component is 28m plus 12b minus 36, and we found the second component is 12m plus 6b minus 16. And for any value of m and b, we can calculate this. Do you agree? Now we have to set a learning rate, lambda. Who would like to? I'm not going to let you all select a learning rate because this is very sensitive. Basically, if the learning rate is too large, what happens? You just jump around constantly and you never get anywhere. You overshoot. And now what if happens if learning rate is too small? There, but it takes forever. So I'm going to get what I hope is a reasonable learning rate. Even if we don't get to convergence, if we do like 5 iterations of this, it will be sufficient to understand the idea.